Start. Hello everyone, this is our 8th SEM project whose name is Design and Development of Wireless Industrial Pyrometer. As you can show, the front part of this body is consist of thermopile detector and laser indicator. Thermopile detector is from Remain company whose temperature range is -40 to 380 degrees Celsius and distance to spot ratio is 8:1. It has also inbuilt 5.5 mm lens. The laser indicator indicates where we want to measure the temperature. Now there is a 16 cross 2 LCD where we can display our temperature. Right now it indicates room temperature. Above that there is a Arduino port where we can program it. Here we used Arduino Uno controller, which is main part of our circuit. Now besides this, there is a Zigbee port where we can configure modules and transmit our temperature data through wireless communication. We used a Series 2 Zigbee module whose range is up to 100 meter. The orange part of this body is push switch which can hold continuous supply to the circuit. The blue part of our body is 9-volt battery which gives power supply to whole circuit. And the last there is also alarm system in the body which make buzz noise when it crosses lower and higher limit of temperature. Here we measured the temperature of ice. As you can show, this is a thermocouple and this is a pyrometer. We measure the temperature of ice. Here the temperature of thermocouple, and now this is the temperature of pyrometer. As you can show, the beep noise is the lower limit, crossing the lower limit. Now we are moving on to the cold water temperature. Now we measure from the thermocouple, sorry. This is the temperature of pyrometer. Measurement from the pyrometer. Now we moving on to the normal room temperature water. Now we measure from thermocouple. Now we measure from the pyrometer. Now we moving on to the hot water temperature. Now we measure from the thermocouple. As you can, this is increasing the temperature. Now we measure from the pyrometer. Now we moving to the cold temperature. Now we moving to the cold temperature. First we measure from the thermocouple. Now the response of the thermocouple is slower, so it takes times to heat up. Now we measure from the pyrometer. The beep noise is showing the higher limit of the pyrometer, which is 200. Here we perform the wireless communication through Zigbee. For that, we have to configure two Zigbee modules using Executive software. First, we have to find the modules and add into the Executive. Then we have to read the profile. As you can show in the screen, we have to add the devices. First Zigbee module is now added to the XCTU software. Now another one. Both the Zigbee modules are connected to the XCTU software. Now we have to read the profile of it. So we have to click on it. First module profile is load. Now another one. The earlier one is coordinator and this one is router. The router profile is also load. Earlier we done the profile bar of it, and the Zigbee saved that profile until we change that manually. Now for the communication, we have to go to the console log. For that we have to close the console log of the both module. Now we have to detach one console log, and we have to check the whether the communication is done or not. For that we have to send the message hi. As you can show that I just type one of the console log, and the another it transmit to another console log. Now for we can get the data in our PC up to 100-meter range. For that uh, we have to uh, we have to connect the 3 pins of the Zigbee to Arduino, which is 5 volt ground, and TX pin of the Arduino to RX pin of the one of the module Zigbee module, which receives the data from the Arduino, and then it transmits data through the wireless network to another module, which is far from the first module connected to the PC, where we can see the data of the temperature in our computer screen. We connected the 3 pins of the Zigbee to Arduino, which is 5 volt ground and TX of the Arduino to RX of the coordinator module. Right now we are in another place far from the router module, approximately 50 meters. Now I am moving to the router module, where we connected to the PC, and my friend is still at that place with the pyrometer, which is approximately 50 meters. We take some time to moving towards the router module, so you guys can wait for some time. And as you can show that we getting our temperature data in our PC, we can also save this data in our PC. And we can also save this data, and so we perform our whole project and getting our results successfully. And as you can show, our friend is still there out there in to the 50 meters. Thank you so much guys for listening it carefully.